syllabus today, and I need to cover around 110 slides for this unit vector, right? So in our today's session we'll discuss the concept of multiplication of vector, that is scalar and vector multiplication. Also we'll discuss the scalar and vector triple product, differentiation and integration of vectors, tangent vector, unit vector, and divergence curl of a vector, right? So let's start with the definition of vector. What is vector? A quantity which possesses both magnitude and direction. It is called vector, right? If we could find the direction as well, then it is known as vector. We can add, subtract and multiply the vector quantity, but we cannot divide it, right? For example, displacement, velocity, force, acceleration, all are vector quantities. Clear? Here we have one example for the vector. Suppose a boy is going to school, so he start with his home and let the distance of his school is 5 kilometers. This gives the sense of direction and distance both, right? So it is a vector. Representation of vector. A vector is represented by this arrow, right? Let's say if the distance is OA, right? So we can represent it as OA and then that kind of arrow on that, right? The magnitude of vector is indicated by the length of arrow. The trail end of the arrow O is called the initial point or the origin of the vector, and the head is called the terminal point of the vector, right? We can denote it as this notation B. This is pronounced as B vector. If this arrow is put on B, then it is known as vector, and its magnitude is denoted by mod B. Clear? Now unit vector. Unit vector is a vector having unit magnitude. If vector B is not equals to 0, then vector B upon mod B is the unit vector. The rectangular unit vector along x, y, z axis are I cap, j cap and k cap. In general, we have these three directions, that is x axis, y axis and z axis. So along x axis the unit vector is I cap, along y axis it is j cap, and along k axis it is k cap, right? Two vectors are considered to equal if they have the same magnitude and direction. If a vector has 0 magnitude and the direction is undefined, then it is represented as 0 only. Clear? We have two representations of vector. One is coordinate and second is matrix form. Coordinate form x I cap plus y j cap, that is the coordinate form. On graph, how we can represent it? Let's say I need to write this point 6 and 7, right? So this is 6 I cap plus 7 j cap, because on x axis the unit vector is I cap, and on y axis the unit vector is j cap. So it is 6 I cap plus 7 j cap, right? Or in coordinate system we can write it as 6 and 7. It can also be represented by the matrix. We can represent it in the column 6 and 7, that is 6 I cap plus 7 j cap, right? The positive angle are measured in the anti-clockwise direction from horizontal line, and the negative angle are measured in the clockwise direction. For example, this angle is calculated through this line OA, or we can say x axis, in the anti-clockwise direction, then it is known as it will be positive. If we calculate it in the clockwise direction, then it will be negative. Like here, if we calculate this in anti-clockwise direction, this angle AOB is 90°, and if I calculate it in the clockwise direction, then this angle AOB prime is minus 90°. Clear? Here we have some examples how we can represent the vector in matrix form. Like I have a matrix minus 10 I cap plus 7 plus j cap, that can be written as minus 10 and 7 in the column. This is the matrix representation. Similarly for the second one, 1 by 2 and 3 by 7. For the third one, root 2 and 5 by 3. Need not to write I cap and j cap while writing or representing the vector in matrix. Now the reverse form, if the vector is represented in the matrix form, how we can write it in the normal form, that is 7 I cap plus j cap, or 4 by 7 I cap plus 9 by 7 j cap, or 3 I cap plus 9 by 5 j cap. Clear? Which of the following pair of vectors are equal? I have two pair of vectors and I need to find which pair is equal. Both the vectors are equal as the magnitude and direction of both the vectors are same, right? How we can say that magnitude is same? 8 by 2 is 4 and 8 by 4 is 2, right? 8 by 2 I cap plus 8 by 4 j cap. So 8 by 2 can be written as 4 and 8 by 4 can be written as 2 j cap, right? And the second is 4 I cap plus 2 j cap. So both the vectors are same. Similarly, here if I take 2 common, 2 I cap plus 2 j cap, if I take 2 common, it is I cap plus j cap. Clear? But here this term is not equals to I cap plus j cap. The magnitude is not same, so this vector is not same. Here now here we have few examples of scalar and vector. Scalar in which the direction is not given, like area. If I say that this is the circle, find the area of the circle, right? So direction is not at all important while finding the area, so it is a scalar quantity. Next is gravitational force. As we know, gravitational force is always in the downward direction. So it is vector because it is showing the direction as well, right? Similarly, all other terms are there. Now vector addition. To find the vector addition, we have two rules. One is head to tail and second is parallelogram. So how to add head to tail? Let's say I have first vector, that is O to A, and the second vector is O to B. So we can write it, if I want to find the addition of these two vectors, so we can draw it like that, O to A and A to B. And this is the third line, and we can say that A plus B is equals to C, right? Similarly, if I have more than the two vectors, so addition of vector is A plus B plus C plus D plus E and plus this one is the resultant vector F. So this resultant vector F is addition of all the other vectors. So it is known as head to tail because here we are adding head to tail, right? So here also head to tail, head to tail, head of B and tail of C, head of C and tail of B, like that, right? So it is head to tail method. Next is parallelogram law. Draw vector 1 using appropriate scale and in the direction of its action. From the tail of vector 1, draw vector 2 using the same scale in the direction of its action. I have drawn vector F1, force F1, F2, right? Complete the parallelogram by using vector 1 and 2 as side of the parallelogram. The resultant force is represented in both magnitude and direction by the diagonal of the parallelogram. So the resultant force is drawn by the diagonal of the parallelogram. Let's say the force 1 is in that direction, force 2 is in that direction. So the resultant force will be in the direction of diagonal of the parallelogram. Then vector subtraction. Similarly, we can subtract the vectors. This is the graphical representation. We have two vectors OB and O minus B, right? One is given by B, vector B, and one is given by minus vector B. So it is, let's say I have two vectors, vector A and vector B. So resultant vector will be A minus B. Clear? Vector addition is commutative as well as associative. Vector addition satisfy both these properties, but vector subtraction is not commutative. Here we have few examples on the sum and addition and subtraction of vectors. Here we need to find the addition of vector I plus 2 j cap, I plus 2 j cap plus 5I plus 6j. So how we can find the addition of vectors? We just need to add the coefficient of I cap, that is coefficient of I cap is 1 and coefficient of I cap is 5. So 1 plus 5 is 6 I cap. Similarly, coefficient of j cap is 2. Here coefficient of j cap is 6. So it will be 8 j cap. Coefficient of j cap is 2 and coefficient of j cap here is 6. So addition will be 8. Clear? Similarly, if I take the second example, 2 I cap minus 5 j cap plus 3 I cap plus 2 j cap, right? So addition of I cap is 2 plus 3, 5. Similarly, addition of j cap minus 5 plus 2, that is minus 3. Clear? Similarly, we can find the second one as well. In the similar manner, we can find the subtraction of the vector. Let me explain here also the subtraction of vector. Although question is asking for addition only, but I need to explain the subtraction of vector. So I plus 2j, this example, I plus 2j minus 5I plus 6j, right? So addition will be, again coefficient of vector is 1 minus 5 and coefficient of vector is 2 minus 6. So minus 4 I cap minus 4 j cap. Clear? This is the subtraction of vector. Clear? Also we can check the commutativity A plus B is equals to B plus A. We can see that we are just adding the coefficients. So 1 plus 5 is also equals to 5 plus 1, right? So A plus B is equals to B plus A. So addition is commutative. Next, the component of vectors. The meaning of component is parts, right? Any vector quantity in two-dimensional means it has two parts. One is in the one direction, like in this x direction, and the another is in the another direction, right? So these two values are known as component. For example, if I have a vector p1 I cap plus p2 j cap, so p1 and p2 are two components, right? P1 I cap is in the direction of x axis and P2 j cap is in the direction of y axis, right? And the magnitude of any vector, that is mod P, can be written as root coefficient of I cap square plus coefficient of j cap square, that is P1 I whole square plus P2 whole square. This is the magnitude of the vector. Clear? Here we have two examples based on the magnitude of the vector. I cap minus j cap plus k cap. So coefficient of I cap is 1, coefficient of j cap is minus 1 and coefficient of k cap is 1. So just square and add and take the square root, then it is root 3. Similarly, 2 square plus 2 square plus 3 square. This is the end root, addition and root. That is the magnitude of the second vector. Similarly, root 3 square plus minus 2 square, that is 13. Clear? Here we have a few more examples. That is r, vector r is 5 I cap minus 2 j cap plus 3 k cap. R2 and R3 is given. We need to find the magnitude of R3. Magnitude of R3 is root minus 2 square plus 1 square plus minus 3 square. This is the magnitude of R3. Then R1 plus R2 plus R3. First I need to find the addition of these two vectors, R1 plus R2 plus R3. The coefficient of I cap is 5, here it is 1 and here it is minus 2. So 5 plus 1 minus 2, that is 4 I cap. Now minus 2, minus 1 and 1, that is minus 2 j cap. Then 3, minus 1 and minus 3, so it is minus k cap, right? This is R1 plus R2 plus R3. Now magnitude of R1 plus R2 plus R3, again root, coefficient of I cap is square, coefficient of j cap is square and coefficient of k cap is square. Similarly, we can find 2R1 minus 3R2 minus 5R3. The third part, 2R1 minus 3R2 minus 5R3. So 2, the value of R1 is 5 I cap minus 2 j cap plus 3 k cap. Minus 3, the value of R2 is I cap minus j cap minus k cap. Minus 5, the value of R3 is minus 2 I cap plus j cap minus 3 k cap. Now collect the coefficient of I cap. 5 into 2, 10, minus 3 and minus 10. So it is minus 10 minus 3 and plus 10. Sorry, so 20, it is 20, 20 minus 3, 17. 17 I cap. Now minus 4 plus 3 and minus 5. So it is minus 6 j cap. Then similarly we can write the coefficient of k cap, that is 24 k cap. Right, and then magnitude of this term will be 17 square minus 6 square plus 24. Clear? Now multiplication of vector. First let me take your questions. If you have any problem in that part of vector, please raise your hand. Yes, Rakshit, please unmute yourself and you can ask your question.
Ma'am, good afternoon.
Very good afternoon.
Ma'am, can you repeat the last one question?
The last,
the magnitude of the last part.
this is not my PPT, this one is this one, 2R1
Yes.
minus 3R2
Yes.
plus 5R3. So
Yes,
let me add one slide over there. Right, so 2R1 minus 3R2 plus 5R3. So the question is 2R1 minus 3R2 plus 5R3 and I need to find the magnitude, right? So first of all, the value of 2R1 is 2, 5 I cap minus 2 j cap plus 3 k cap, right? So it is 10 I cap minus 4 j cap and 6 k cap. Minus 3R2 is minus 3 I cap minus j cap minus k cap. So it is minus 3 I cap plus 3 j cap plus 3 k cap. And 5 R3 is 5 minus 2 I cap plus j cap minus 3 k cap. That is minus 10 I cap 5 j cap minus 15 k cap, right? Then 2 R1 minus 3 R2 plus 5 R3. That is addition of all these terms, that is 10. It is minus 5 or 5 or minus 5 R3, I'm sorry. That is minus 5 R3. So 10, that should be minus and plus, right? Now addition is 20 minus 3, 17 I cap. Now 4 minus 4 plus 3 and minus 5. Minus 6 j cap, and it is 24 k cap, right? Now magnitude of 2 R1 minus 3 R2 plus 5 R3, I mean minus 5 R3. The magnitude will be root 17 square minus 6 square and 24 square, right? Clear?
Okay, ma'am.
Any other query?
No, ma'am. Thank you.
Okay. So let's start with the multiplication of vector. Here also we have two type of multiplication, that is scalar product and vector product. Clear? So let's discuss. I'll not discussing these terms over there. I'll discuss scalar and vector product through examples. First of all, if A and B are two vectors, then the scalar product of A and B is defined by A dot B, that is vector A, I mean magnitude of A, magnitude of B, cos theta, where cos theta is the angle between the two vectors and it is known as dot product, right? A scalar product comes into existence while finding the formula of angle between two vectors. If two vectors are perpendicular, then the theta will be 90 and cos 90 is 0. So A dot B will be 0, right? If two vectors are parallel, that means the angle theta is 0 degree and cos 0 is 1. So A dot B is magnitude of A times magnitude of B. And if A is equals to B, it is A square, right? Now we can find work done through dot product. Work done is force dot product displacement, right? Force and displacement both are vector quantity. Now we have few properties of dot product, like u into v is equals to v into u, it is commutative. Now k times v dot w is equals to v dot kw or k v dot w. V0 is equals to 0. This is associativity, and magnitude of VW is less than equals to magnitude of V, magnitude of W. Here I am explaining the product, how we can find the product. Before that, we need to, here in the remarks section, I would like to write I dot I is equals to j dot j is equals to k dot k is equals to 1, right? and I dot j or j dot k or k dot I is 0. This is the property of dot product, right? For example, we have two vectors 2 I cap plus 3 j cap plus 6 k cap and 4 I cap minus 7 j cap plus 2 k cap. And I need to find the dot product of A and B, right? How we can find? I just write vector A dot vector B. Dot is must. You need to write the dot. In vector, dot is a particular meaning. If you write it in that sense, without using any dot, these two equations are not same. Please note, in vector these two equations are not same, because here we are not using dot product, but here we are using dot product, right? So dot is very important in vector calculus, so don't take it lightly, right? Now multiply as usual, like 2 I cap times, but remember we need to put this dot. So 2 I cap dot 4 I cap, right? Then 2 I cap dot minus 7 j cap. Then 2 I cap and 2 k cap. 2 I cap dot 2 k cap. 3 j cap 4 I cap. 3 j cap dot 4 I cap. 3 j cap minus 7 j cap with dot. 3 j cap 2 k cap. 6 k cap 4 I cap. 6 k cap minus 7 j cap minus 7 j cap with dot, and 6 I cap plus 2 k cap, right? 6 k cap and dot 2 k cap, right? Now we have a property I cap dot I cap, j cap dot j cap and k cap dot k cap is 1 and rest terms are 0, right? So here we have I cap dot I cap. 4 into 2 is 8. I cap dot I cap is 1. In this term, I cap dot j cap, I cap dot k cap is j cap dot I cap is 0. So these terms will be 0, right? Now here again 7 into minus 7 into 3, that is minus 21. J cap dot j cap is 1. Now again j dot k 0, k dot I 0, k dot j 0, and then k dot k, that is 6 into 2, 12. K dot k is 1, right? And after simplification we can write it as minus 1. Getting my point? Yes. So you need to multiply 2 I cap 4 j cap, 3 j cap minus 7 j cap and 6 k cap 2 k cap. Rest term will be 0, right? Now find the angle between these two vectors. So formula is angle between two vectors is A dot B is magnitude of A, magnitude of B cos theta. We have vector A, we have vector B. We can find the dot product for A and B. We can find the magnitude of A and B. So by substituting all the values, we can find the value of theta, right? So magnitude of A is root 2 square plus 2 square plus minus 1 square. Magnitude of B is 6 square minus 3 square 2 square. Right, so magnitude of A is 3, magnitude of B is 7. And A dot B, what will be the value of A dot B? Just 2 I cap and 6 I cap, that is 12. 2j cap and minus 3j cap, that is minus 6, and minus k cap plus 2k cap, that is minus 2. So the resultant is 4. A dot B is 4. Right? So A dot B is 4, magnitude of A is 3, magnitude of B is 7, and times cos theta. And after cross multiplication, we can find the value of cos theta or theta. Clear? Show that the vectors are at right angle. They are at right angle means what? The angle theta is 90 and cos 90 is 0. That means A dot B is equals to, formula is magnitude of A, magnitude of B cos theta. And if theta is 0, that means this right hand side is 0. So it should be, A dot B should be 0. We need to find just the dot product. That is 9 into 4, 36. 1 into minus 6, and minus 6 into 5, 30, minus 30. And the total is 0. Hence, these two vectors are at right angle. Clear? Now we need to find that find the value of A such that vectors are perpendicular. Vectors are perpendicular means again angle theta is 90. Perpendicular or right angle or theta is 90, all are same terms. So if theta is 90, that means dot product should be equals to 0, right? So we just find the dot product, equate it to 0. So the value of A can be find, that is 3. Now the cross product. Okay, let me take your questions first. If you have any problem, you can raise your hand. I'm sorry. No? If you have any problem, please raise your hand. Okay, fine. So let's start with this cross product. That is denoted by this cross sign. It is known as cross product C cross D. That is magnitude of C, magnitude of D sine theta. Right? How we can find C cross D? We write it in the determinant form IJK. Coefficient of I cap, J cap and K cap, that is C1, C2, C3. Here D1, D2, D3. Right? Then solve this determinant I cap. Just hide this row and column and write the remaining matrix in the determinant form. That should be in alternate plus minus, that means minus J cap. Again they hide this row and column in which J exists and write the remaining terms in the determinant. Similarly for K cap. Then coefficient of I cap is C2 times D3 minus D2 times C3. Similarly for this remaining term. So this is the cross product. If we consider vector product of unit vectors as I cap, J cap, K cap are mutually perpendicular, then how we can learn this? So I cap, J cap and K cap. Write it in this circular motion, draw the arrows like that, right? Now I cap cross J cap I cap cross j cap is k cap. J cross k is I. Remember, we are moving in this direction only, anti-clockwise direction. Then k cross I is j, right? If if you move in the reverse direction, like j cross I, that will be minus k. Clear? And I cross I, j cross j, k cross k is 0. In the dot product, I dot I is 1, j dot j is 1, k dot k is 1, and in cross product it is 0. Clear? Now the area of the triangle is 1 by 2 magnitude of u cross w, where u and w are adjacent sides. These are the application of cross product. The area of parallelogram with adjacent sides v and w is magnitude of v cross w. Now vector product is not commutative, that is c cross d is not equals to d cross c. In fact, c cross d is equals to minus d cross c. Clear? Now few properties of vector. U cross v plus w, that is associativity, a simple associative law. These two are the simple associative law. If k is any constant, or I should say any scalar, then we can shift this k with w, or we can take it out with v and w, cross product of v and w. If 0 is any vector, if 0 is any vector or any scalar, then cross product with any vector is 0 itself. This property is important. U cross v cross w is u dot w times v minus u dot v times w. Clear? For example, I have a vector a, b and c, and I need to find a cross b. How I can find a cross b? I just write I cap, j cap, k cap in the first row. The coefficient of A is 1, 0, 1, and the coefficient of B is 2, minus 1 and 3. Right? Now I cap, the coefficient of I cap is 0 into 3 minus into 1. 0 into 3, this dot means multiplication, simple multiplication. Minus 1 times 1. Then minus j cap, 1 into 3 minus 2 into 1. Then k cap, 1 into minus 1 minus 2 into 0. So this is the cross product of A and B. Similarly, we can find A cross B plus C and A cross C. This is one more example. Here B cross B. Although we know that the cross product of same vector is 0, but we can solve it. Also, we know that if two rows of the determinant is same, then the determinant is 0, right? And we can find B cross A and A cross B cross C by using this determinant. Here we are we prove that A cross B is equals to minus B cross A. First of all, we find A cross B, then we find minus B cross A, and both the values are same. So we can say that this cross multiplication is not commutative. This is the application based question. Calculus the area of the triangle where A, B and C is given like that. So vector A coordinates are 2, 4, minus 7. That is 2 I cap plus 4 j cap minus 7 k cap, right? Similarly, B and C. And we need to find the area. So we know that it is 1/2 times magnitude of V and W, where V and W are adjacent sides. So you can take any two adjacent sides. Here I took here I took the first side AB and the second is AC. So AB and AC, by the distance formula we can find the value of AB, that is 3 minus 2 1 and 7 minus 4 3 and 18 minus of minus 7, that is 25. So this one is AB. Similarly AC, that is C coordinate minus 5 minus 3, that is minus 8. Sorry, AC minus 5 minus 2. I'm sorry. Minus 5 minus 2 minus 7. 12 minus 4, 8. And 8 minus of minus 7, that is 50. So this is AC and this is AB. Right, so first of all we find the cross product of AB and AC and then we find the magnitude. This is the area. Here we need to find the area of the parallelogram where PQRS are given. Similarly, we can take any two adjacent sides. Here I took SP and SR. SP and SR. By distance formula, we can find the vector V and W. Then we can find the cross product of V and W. And by taking the magnitude, we can find the area of parallelogram. Right? Okay, let me take your questions now. Yes, John. Please unmute yourself, John. John, if you want to ask something, please unmute yourself.
Yeah, ma'am. So the last section, right? You mentioned like the not here, the previous one. That a parallel vector was there, right? How to find that parallel vector values?
You are talking about which question? This one?
No. Previous one, before starting this one, the multiplication.
Vector product?
Yeah. Yeah, this one. Here that yeah, 30. Yeah.
Determine the value of A such that vectors are perpendicular. This one?
Yeah, right. Perpendicular one. Sorry.
Yeah. So perpendicular means, what is the meaning of perpendicular? If two vectors are at 90 degree, right? This one is, let's say, vector A. This one is vector B, right? If two vectors are at 90 degree, that means it is perpendicular. Perpendicular, right, or right angle or theta equals to 90, all terms are same, as I mentioned it earlier, right? So A dot B, vector A dot B, the formula is angle between two vectors is magnitude of A, magnitude of B cos theta. Now theta is?
Theta is 90.
90. And cos 90 is? 0. The value of cos 90 is 0. Right?
0.
So if I multiply it with magnitude A, magnitude B, it will be 0. So A dot B should be 0. If both the vectors are at 90 degree, that means the dot product of the vector should be 0.
0.
Right? Now question is saying that both the vectors are perpendicular. It is already mentioned in the question that both the vectors are perpendicular, and I need to find the value of A.
Okay.
Right? If both
Yeah.
the vectors are perpendicular, that means this condition should satisfy by the vectors, right? So I just find A dot B. How I can find A dot B? 2 into 4, that is 8. I dot I is 1. A into minus 2, that is minus 2A. J dot J is 1. And K dot K is again 1 and minus 2. And that should be equals to 0 by this condition. This dot product should be 0.
Okay. Okay. Yeah.
So the value of A is 3. Any other?
Okay. A will be 3 then. Yeah. Yeah. Got it. Now I got it. Yeah. Thanks, ma'am.
Thank you. Any other question? No? So the next is differentiation of vectors. This is the differentiation of vector. If I have a vector R, that is R1 I cap plus R2 j cap plus R3 k cap. Let's say this is vector R. Then vector R, differentiation of vector R with respect to t is dr1 by dt I cap, dr2 by dt j cap, and dr3 by dt k cap. Right? I cap, j cap and k cap are directions. So we need not to differentiate I cap, j cap, k cap. It will remain same. Only we need to find the differentiation of R1, R2 and R3. Clear? For example, if vector R is 3t cube I cap plus 3 cos t j cap plus t square k cap, and I need to find the first order, second order and third order derivative, right? So dr by dt is 3, this 3, differentiation of t raised to 6, I cap will remain unchanged. Then again this 3, differentiation of cos t, j cap will remain unchanged. Then differentiation of t square and k cap will remain unchanged. So differentiation of t raised to 6 is 6t raised to 5. I cap plus 3, differentiation of cos t is minus sin t, j cap, and differentiation of 2 square is 2t and k cap. This is first order differentiation. Now if I find the second order differentiation, that is differentiation of this term, right? 6 into 3, 18, this is constant. Now differentiation of t raised to 5 is 5t raised to 4 I cap minus this minus sign and this 3. Differentiation of sin t is cos t, j cap, plus 2. Differentiation of t is 1, k cap. Then third order differentiation, 18 into 5, and differentiation of t raised to 4 is 4t cube. Differentiation of cos t is minus sin t with j cap, and differentiation of 2 k cap is 0 because 2 is constant, k cap is the direction, it is constant. So this is the third order derivative. Clear? Differentiation is clear? Fine. Now the basic properties of vector, if c is any constant, all the properties are like the normal derivative properties. If c is constant, then derivative of c is 0. If k is any constant and f is any vector or scalar, we can take it out with the derivative. If f plus g, we have two terms, two vectors f and g, we can partially differentiate it. Similarly for the subtraction, u into f, this is the usual multiplication formula for derivative, right? This one is for dot product and this one is for cross product. Clear? Now velocity of the vector is first order differentiation of the vector, acceleration is second order derivative of vector, and kinetic energy is half mv square, where v is the velocity. Clear? Monica, are you there?
Yes, ma'am.
Monica, can I take 5-minute break because I am feeling little bit congestion in my throat, so I need to take some hot water.
Yeah, sure, ma'am. Sure,
Yeah.
ma'am.
So I'm just taking 5 minutes break. Hello. Shall we start? So velocity is first order derivative of vector, acceleration is second order derivative of vector, and this is kinetic energy. Now let's say if I have this vector that is t square 2t cube and minus 5t. This is in the coordinate system, right? So vector r can be written as t square I cap 2t cube j cap minus 5t k cap. At time t equals to 0, we need to find the velocity and acceleration. Velocity means first order derivative and acceleration means second order derivative, right? So first order derivative means differentiation of this term. Differentiation of t square is 2t. I cap remain unchanged. 2t cube, that is 6t square minus 5 k cap. At t equals to 0, that means we need to substitute t equals to 0 over there. So it will be minus 5 only. This is the velocity, and at t equals to 0, velocity will be minus 5 because we substitute t equals to 0 over there. Now acceleration, second order derivative means differentiation of velocity. So differentiation of this term is 2 I cap 6 into 2 12 t j cap, and minus differentiation of minus 5 is 0, right? Now if I need to find the acceleration at t equals to 0, it is 2 I cap t is 0, that's it, right? Here also we need to find velocity, acceleration, kinetic energy for the particle of mass m whose positional vector is this. Verify that for such a particle v dot r is 0. Yes, so velocity, first of all we need to find the velocity. This is first order derivative. Then v dot r, v is the velocity and vector r which is given in the question. We need to find the dot product of these two terms. So v dot r is 0. Both terms will cancel out, right? Similarly, acceleration, the second order derivative, and kinetic energy is half mv square. Half m will remain unchanged. V square, that is velocity square, that we have found in the previous slide, right? A particle moving along the curve this xyz, the value of xyz is given. Find the component of velocity and acceleration at time t equals to 1 in this direction. So we can find velocity. This is first order derivative. At t equals to 1, we can find velocity at t equals to 1 by substituting t equals to 1. Right? So this is one is velocity at t equals to 1. Now I need to find the velocity in this direction. What it means? How I can find the velocity in this direction? The unit direction will be vector itself, that is I cap minus 3 j cap plus 2 k cap upon root coefficient of I cap square, coefficient of j cap square, coefficient of k cap square. This is the unit vector in this direction, right? Then we need to find the dot product of velocity and this dot product. Let's say it's a cap. Usually the unit vector is denoted by a cap, right? So v dot a cap is 4 I cap minus 2 j cap plus 3 k cap. This is vector v dot I cap minus 3 j cap plus 2 k cap upon root 14. I cap dot I cap is 4. J cap dot j cap is minus plus 6 and plus 6 upon root 14. So this is the velocity in this direction. Clear? First we need to find the unit vector in this direction. How we can find it? Vector itself upon root coefficient of I cap square plus coefficient of j cap square plus coefficient of k cap square. Then we need to find the dot product of velocity and unit vector. Like that. Similarly, the acceleration, we can find the acceleration and we can find the acceleration at time t equals to 1. Then again we can find the acceleration in the direction of this vector I cap minus 3 j cap plus 2 k cap. So we just use this unit vector, acceleration dot unit vector. Now the next is integration. Your questions first. If you have any query in derivative of differentiation of vector, please raise your hand. No? Fine. So the next is integration of vector. It is like differentiation. If I need to find the derivative of the vector, if I need to find the integration of the vector, I'll integrate all the terms separately, like integration with respect to I cap, then integration with respect to j cap, and integration with respect to k cap, right? Integrate all three terms separately. This is the integration. Example, this is the vector r and I need to find the integration of this term, and the limit is 1 to 3. The limit of the integration is 1 to 3. So integration of I cap under the limit 1 to 3, then integration of the component of j cap and k cap. Integration of 3t square is 3t cube by 3. Integration of 4t is 4t square by 2. Then we'll apply the upper limit minus lower limit. Right, let me solve this question once. 1 to 3, 3t square minus 4t plus 4t dt I cap. So 3t cube by 3 plus 4t square by 2. 1 to 3. Right? Upper limit is 3 cube minus 1 cube plus 2 3 square plus 1 square. Right? And I cap, it is coefficient of I cap. Similarly, we can solve for j cap and k cap. Now we have two vectors f and v, and we need to evaluate integration of f cross v. So first of all, we need to find the cross product of f and v. How we can find cross product? I cap, j cap, k cap. The coefficient of I cap, j cap, k cap in f. Then coefficient of I cap, j cap, k cap in v. And then solve this determinant. This is f cross v. Then we need to find the integration of this term. Just find the integration of each and every term, term of I cap, j cap and k cap, and then apply the limit 0 to 2, that is upper limit minus lower limit. Now we have three terms, that is gradient, curl and divergence. Now we'll discuss these three terms. Right? What is gradient? Gradient is a scalar multiplication with Dale operator. This is the Dale operator. So if we have the scalar multiplication with this Dale operator and any vector, then it is known as gradient. This notation is known as nabla, right? So gradient f is nabla f. Then divergence, this is the dot product with this operator, and curl means cross product with this operator. So D stands for dot and D stands for divergence. C stands for curl, C stands for cross, and rest is gradient. This is the way how you can learn what is gradient, divergence and curl, right? Here we have few properties of gradient. A dot Dale operator f, where A is any constant vector, can be written as A dot Dale f. Gradient is a constant, gradient of a constant function is 0. If f and g are two scalar values, then gradient of f plus minus g is gradient f plus minus gradient g. And similarly, f and g are two scalar values, then gradient of f dot g is equals to f gradient g plus g gradient f. Similarly for the division property. Here I have few example based on the gradient. I need to find the gradient of this function, right? That means this is the operator del by del x I cap plus del by del y j cap plus del by del z k cap, and this is our function. So just write this function with all three terms, I cap, j cap and k cap, and then differentiate this term with respect to x, y and z. Now we can see that this function is a scalar, right? A scalar means I cap, j cap, k cap are not exist in this function. But once I get the gradient of this function, it convert into vector, right? So gradient of the function is a vector quantity. That is written in the remark. Gradient is a vector quantity. If a vector value function, then gradient is meaningless. We cannot find gradient for the vector function. Gradient is normal to the surface. What is gradient? Let's say I have this surface, right? And this one is the tangent of the surface, and this one is the normal. Normal is what? Perpendicular to tangent. So this normal is denoted by gradient f, where f is the surface, right? This is the geometrical interpretation of gradient. Similarly, if I have one more vector and I need to find the gradient at the point 1, minus 2 and 1, again just write this Dale operator Then write the function. Multiply this function with every term of the operator. Differentiate the function with respect to x, y, z. Now I need to find the gradient at the point 1, minus 2 and 1. Substitute x equals to 1, y equals to minus 2 and z equals to 1 in this function. So you'll get the gradient at this point 1, minus 2, 1. Right? There are also some examples of gradient. Then we can find arc length as well. This is the arc length. If the total distance traveled by the particle from time A to B is defined as this term. This is the arc length, root dx by dt whole square plus dy by dt whole square plus dz by dt whole square, integration along A to B. Here we need to find the length for this function from t equals to 0 to pi. So first of all, I need to find this one is our function, that is sin t I cap plus cos t j cap plus t k cap. Then we need to find the derivative, right? Then put the coefficient of I cap, take the square plus coefficient of j cap whole square plus coefficient of k cap whole square, then take the root under the limit 0 to pi, integrate under the limit 0 to pi. So this is the arc length. Here we have one more formula for arc length. This function can be written as t I cap plus t sin t j cap plus t cos t k cap. Then we find the derivative of the function, right? Then we put the value of value in the formula for arc length. Similarly, these are basic examples to find the arc length. Then the tangent vector. If r is a vector, then the tangent vector is defined by r prime provided it is not equals to 0. If exists, tangent line to r at some point, say A, is line which passes through the point A and parallel to the tangent RT. The unit tangent vector of the curve is given by r prime upon magnitude of r. Right? So find the tangent vector and unit tangent vector for this curve. Vector r is given, we can find the r prime, that is differentiation of vector r. This is tangent vector, and unit tangent vector is vector r upon magnitude of r. What is magnitude of r? Root coefficient of x square, coefficient of I cap square, coefficient of j cap and coefficient of k cap square. So this is unit tangent vector. Right? Now unit normal vector. What is unit normal vector? Gradient of f upon magnitude of gradient f. For example, I have this vector and I need to find a unit normal vector at point 1, 0, 1. So first I need to find gradient f and its magnitude, and I'll divide both the terms and put x equals to 1, 0 and 1. Right? So gradient f, del operator, multiply, this dot should not be there. It is a simple multiplication. So gradient f, dot should not be there. It's a typo error. Del by del x I cap, del by del y j cap, and del by del z k cap times the vector x cube y x z square y square z and 2. Now del by del x of whole this term, that is 3x square y plus z square I cap, del by del y of this term, that is x cube plus 2yz j cap, and del by del z of this term, that is 2 x z plus y square k cap. This is grade f. Now I need to find the value at point 101. So I just substitute x equals to 101, and then I'll substitute the value on this function formula. Then directional derivative. What is directional derivative? The directional derivative of f at a is the component of grade f in the direction of any vector a cap. So it is grade f dot vector a times magnitude of a, or we can write it as grade f dot a cap, because a cap is vector a upon magnitude of vector a. Right, so this is a directional derivative. So after this directional derivative, I'll take your questions. Find the directional derivative for this function at this point in the direction of this vector. Right, so directional derivative is grade f dot a cap. So vector f is given. First of all, we need to find the grade f. Grade f is gradient f. That is simple multiplication with the vector. This one is my operator, and the vector f is x y square plus x cube y. Right, so I cap y square plus 3x square y, j cap 2xy plus x cube, and k cap will be 0. Right, so this one is grade f. Now v cap is vector v upon magnitude of v. Vector v is 1 by root 2 I cap plus 1 by root 2 j cap. Magnitude is 1 upon 1 by root 2 square 2 square. So 1 by 2 plus 1 by 2 is 1. Denominator is 1. This one is vector v. Now take gradient f dot v cap. This one is gradient f dot v cap. This is the directional derivative, right? Here also we have one more example of directional derivative. You can take, you can do this question. Now divergence. As I told you, divergence, D stands for divergence and D stands for dot product. Divergence means dot product with Dale operator. Right, D stand for divergence, D stand for dot product. Divergence f is dot product with Dale operator. Gradient operator act on a scalar quantity and gives the vector quantity, and divergence act on vector quantity but gives the scalar quantity. Once we find this dot product, we get this scalar. Here no I cap, j cap, k cap exist. Right, so divergence act on vector but give the scalar quantity. If divergence of any vector is 0, then we can say it is solenoidal vector. Now the next one is curl. Again, curl, C stands for curl and C stands for cross product. Right, if curl of the vector is 0, that means it is a rotational or conservative vector. Now this is the geometrical representation of divergence and curl. What is the meaning of divergence? Divergence of the vector field simply measure how much the flow is expanding at a given point. It does not indicate in which direction the expansion is occurring. Hence the okay, fine. So divergence, if divergence of V is less than 0, means the field is conservative. If it is greater than 0, that means it is divergent, right? Now curl of the field measure how the fluid may rotate. This is the geometrical interpretation for curl. Okay. Now let me take your questions. If you have any question, please raise your hand. No question is there? Fine. So let's start with this divergence and curl. Here I have a vector A and I need to find divergence of this vector. That means divergence means dot product with del operator, right? Del by del x I cap, del by del y j cap, del by del z k cap, dot product vector A. So this one is the del operator. A one dot should be there. This is the dot product and this one is our vector A. Now I dot I is 1. So del by del x of this term, del by del y of this term and del by del z of this term, rest terms will become 0. I dot I, j dot j, k dot k is 1. Rest terms are 0. So just find the derivative of these three terms and we can see that this term is scalar. No I cap, j cap, k cap exists anymore because it converted into 1. So divergence applied on the vector and we get the scalar field after applying the divergence. Similarly with the curl applied on the vector and we get the scalar value. What is the curl? Okay, in this question we need to find both divergence and curl. Again, divergence means dot product with this del operator, right? And curl means cross product with this operator. So to find the cross product, we need to draw this determinant, and then we'll solve it. At the point 1 minus 1 1 means x is equals to 1, y equals to minus 1 and z equals to 1. If the vector f is given, we need to compute the value of curl f and verify that del dot del cross f is 0, right? So curl f is cross product. I just write I cap, j cap, k cap, del by del x, del by del y, del by del z, and f is the vector. I cap, j cap, k cap should be written over there, right? So this one is our curl f. Now I need to find del dot del cross f. Del cross f is already written over there. This one is del cross f. Del is again this del operator and dot product with this, right? So del by del x of this coefficient, del by del y of 3z square and del by del z of minus 4xyz. Again we need to find curl of curl f at the point 2 1 1. So first start with curl f. This is curl f, right? This one is curl f. Now I need to find curl of this value. That means again I cap, j cap, k cap, del by del x, del by del y, del by del z, right? And then the value of curl f, that is 2yz 1 minus x, x square y, and xyz minus x square. Then again find this determinant. Clear? Then the line integration. Okay, fine. Let me take your questions as well. If you have any query, please raise your hand. No? Fine. So the next is line integration. line integration is written as f vector f dot dr, where r is x I cap plus y j cap plus z k cap. So dr will be dx I cap plus dy j cap plus dz k cap, right? Vector f, whatever the vector f is, f1, let's say it's f1 I cap, f2 j cap, f3 k cap, whatever the value of f1, f2, f3, dot dx I cap, dy j cap and dz k cap. Just find the dot product, that is f1 dx, f2 dy and f3 dz, right? So this one is line integration. For example, we need to find f dr, that is line integration, where vector f is given and vector r is given, t is from -1 to 1. So first of all, I just write the values of x, y, z. If I say that vector r is x I cap plus y j cap plus z k cap, that means vector dr is dx I cap, dy j cap and dz k cap, right? But here the vector r is 2t I cap, 5t squared j cap and t cube k cap. So x is 2t, the value of x is 2t, the value of y is 5t square and the value of z is t cube. So first of all, I just substitute the value of x, y, z in vector f. Here I substitute the value of x, that is 2t, then the value of y, that is 5t square I cap, plus yz, y is 5t squared, z is t cube, then zx k cap, z is t cube, x is 2t k cap. This is ft. The value of dr by dt is, how we can find dr by dt? Differentiate the right hand side with respect to t. This is dr by dt. Now f dot dr by dt, just find the dot product of vector f and dr by dt. Now take the integration under the limit -1 to 1. Clear? Like in this example, we have this vector and the curve C is a rectangle in the xy plane bounded by y equals to 0. Y equals to 0 means this x-axis. This one is y equals to 0. Then x is equals to a. This line is x equals to a. Y equals to b and x equals to 0. X equals to 0 means y-axis. Right? This is always opposite. Y is 0 means x-axis. And x0 means y-axis. Remember this one. Now I need to find this integration along the curve rectangle in the xy axis. Means I need to find this integration along this line, then this line, then this line and this line, because this is a line integration f dot dr, right? So along OA, first of all OA, then AB, then BC and then CO. OA, AB, BC, CO. So along line OA, look here, the value of y is, on this line the value of y is 0, right? So in f dot dr, if I substitute y equals to 0, it is x square dx, right? And y, if y is 0, that means dy is also 0. So this term will be 0. y0, that means x square dx. Along we are doing integration along 0 to a. The limit of x is 0 to a and y is 0. So 0 to a dx, right? Now if I am moving along this line AB, on this line the value of x is a and the value of dx will be 0. So just substitute the value of x, a and dx 0. So if dx 0, this term will be 0. It is minus 2ay dy. Now the limit of y will be 0 to b. X is equals to a is constant on both the coordinators. So the limit of y will be 0 to d. Now if I move along BC line, that means y is b and dy is 0. So again substitute y equals to b and dy is 0. That means x square plus b square dx. Now the limit of x will be a to 0. A to 0. Now along the line CO, the value of x is 0, the value of dx is 0 and the value of y is b to 0. B to 0. Right? And then simply integrate it. This is the line integration. As simple as that. Clear? Then the surface integral. The next is surface integral. This one is the formula for surface integral. If we have a vector g, then the surface integral can be written by this double integration g1 yz plus g2 dz dx plus g2 g3 dx dy. If I need to find the surface integral by using the projection, so surface integral in the xy plane, this one is for xy plane, I mean this one is for yz plane, this one is for zx plane, and this one is for xy plane, right? These are the formula of surface integration. For example, f is the vector and I need to evaluate this integration, surface integration, and the surface is the sphere above the xy plane, right? So equation of this, I mean diagram of the sphere will be like that. Center is 0 0 0, a is the radius, and above the xy plane, this one is x-axis, this one is y-axis. So this coordinate should be considered. I draw here this circle. Assume it in the 3D direction. Let's say we are discussing about the ball. It is a sphere, perfect example of a sphere. And I need to find the surface integral above the xy plane. Above the xy plane means I need to apply this third one formula. That is vector dot n cap dx dy upon k cap dot n cap. Right? So, this one is the formula. We'll use curl f dot n cap dx dy upon k cap dot n cap, right? First of all, I need to find the curl f. This one is curl f, right? Then we need to find the n cap. N cap is what? Gradient of surface, not gradient, I mean divergence of the surface upon mod divergence of surface, right? That is n cap. Here surface is sphere x square plus y square plus z square equals to a square is also there. You can write minus a square over there, but if when we apply the divergence, a square will be 0, right? So divergence of the surface is this, then we can find the determinant of the divergence of the surface. This one is the n cap. So here we substitute the value of gradient, curl f, then n cap dx dy upon k cap dot n cap. If I find the k cap dot n cap is x I cap plus y j cap plus z k cap by a, right? K cap dot k cap is 1, that means z by a. So this one is k cap dot n cap. Clear? So now we need to find the limit. We need to find the limit of this double integration. That means we need to find the limit of x and y, right? This one is our surface. Let's say x square plus y square plus z square is equals to a square. This one is our surface, right? We are doing integration with respect to x and y. So x square plus y square is equals to a square. Z coordinate will become 0. Now the limit of x is or the limit of y is right. So the lower limit of y is minus root a square minus x square. Upper limit is root a square minus x square. This is the limit of y. By this equation, we can find the limit of y, right? Then hide this y. What will be the value of x? That means the upper and lower limit of x is minus a to a. By this process, we can find the limit. This is all theory which is written over there. Just find the double integration and that's it. Here we have one more formula. Let's say we have this vector and S is the surface of this plane in the first octant, right? And we need to find the surface integral. So first of all, what we'll do, we'll find f dot n cap dx dy upon k dot n cap. So n cap is gradient of the surface upon determinant of gradient surface. Surface क्या है? What is surface? 2x plus y plus 2z minus 6. So first we find the divergence of the surface upon determinant of the divergent surface. So this one is n cap. Then k dot n cap is 2 by 3 because k dot k is 1. Right? Then f dot n cap, vector f is given over there. Find f dot n cap. This one is n cap. Right? Substitute the value over there. The value of f dot n cap, k dot n cap, dx, dy. Clear? Now, how we can find the limit? This is the important question. The equation of the surface is 2x plus y plus 2z. 2x plus y plus 2z is equals to 6. We are taking limit x and y. That means z coordinate will be 0. So 2x plus y is equals to 6. So the limit of y is 6 minus 2x. If I am doing integration in the xy plane, that means the lower limit of y will be 0 and the upper limit is 6 minus 2x. So 0 to 6 minus 2x. Now hide this y. The value of x will be 3. So upper limit of x is 3. Right? Then find simple integration. That's it. Any question? If you have any question, please raise your hand. Hello. If you have any question, please raise your. Yes, Monica.
Ma'am, there are no more queries from the learner side, ma'am.
Okay, so can we conclude this session?
Yeah, sure, ma'am.
Okay, thank you so much.
Thank you, ma'am. Thank you, everyone.
Thank you.
Have a nice day.